You know, we've heard of a great filter, but what about a great blue spot? It's one of the most bizarre mysteries on our solar system's biggest planet. And after 14 years of investigation, scientists are no closer to solving it. Let's look at the weirdest things NASA has ever seen on Jupiter. In 2009, NASA launched the Juno space probe with a simple mission: explore Jupiter. The spacecraft took 5 years to reach the gas giant, and when it finally got there, it was equipped with 9 instruments to analyze the planet's atmosphere, its gravitational field, its magnetosphere, and even its core. But out of all the discoveries that Juno made, none were more shocking than this one. It's an oval-shaped region near Jupiter's North Pole. And at first glance, it looks like any other cloud formation on the planet, except for one tiny detail: it's gigantic. Stretching over 30,000 kilometers from east to west, it would cover the entire United States twice. Meanwhile, from north to south, it only stretches 18,000 kilometers. So what makes this strange spot so special? What does it mean that it's not a storm, and why is it still a total mystery? To answer these questions, let's take a closer look at what exactly we're dealing with here. Officially named the North Equatorial Region, it's basically a localized distortion in Jupiter's magnetic field. And since magnetic fields are invisible, scientists detect them by observing charged particles moving through them. In this case, it's ionized gas from Jupiter's atmosphere, which funnels into the planet's magnetosphere, then gets swept around the planet in Jupiter's infamous jet streams. But instead of just getting swept up in the jet stream, particles entering the North Equatorial Region get trapped there. And at first, scientists thought that might be because they'd run into some kind of obstacle. After all, Jupiter's atmosphere is full of storms and whirlwinds that could slow particles down and keep them from moving further south. But that idea quickly fell apart because the Great Blue Spot isn't actually that big compared to the rest of Jupiter. Its diameter is less than 1% of the planet's diameter. So it wouldn't have been hard for the particles to keep moving south if that's what they were supposed to do. And while scientists were able to rule out a lot of possible explanations, they still don't know exactly what's going on here. But that doesn't mean they haven't come up with a few good guesses. And one of the prevailing ideas is that the Great Blue Spot is sort of like a giant bar magnet. Think of magnetic field lines as being similar to the paths of planets orbiting the Sun. Just as each planet follows its own unique path around the Sun, magnetic field lines follow their own unique paths through space. They can be straight or curved or even twisted into loops. And magnetic field lines can interact with each other in interesting ways. When they connect with each other, energy is released. And when that happens near Jupiter, the energy manifests itself as light. That's why scientists think that if the Great Blue Spot really is a giant bar magnet, the particles getting trapped there must be part of a magnetic field line that connects to another magnetic field line coming from the planet's core. And that connection is what's causing all of those beautiful auroras. But if that's the case, then why aren't the particles just following their field lines all the way down to Jupiter's core? Well, unfortunately, we don't know the answer to that question yet. But we do know that Jupiter's magnetic field isn't static. It changes over time. And that change is tied to what's happening on the surface of the planet. When Juno arrived at Jupiter, it found that the planet's surface was covered in storms, gigantic high-pressure vortices that rage for years. And as far as storms go, some of the biggest ones are pretty easy to spot. Take the Great Red Spot, for example. It's a massive high-pressure storm rising above Jupiter's surface. And it has been around long enough that scientists have been tracking it since 1878. But despite its size and longevity, scientists still don't know exactly how the Great Red Spot works. All they know is that it's a storm and that it's big. Meanwhile, the Great Blue Spot isn't a storm at all. And as far as scientists can tell, it's not even connected to the surface of the planet. But that doesn't mean that it is not related to what is happening on the surface, because as it turns out, Jupiter's storms play a big role in shaping the planet's magnetic field. In fact, the exact opposite of the Great Red Spot is also a gigantic high-pressure storm rising above Jupiter's surface. And here's where things get complicated. Just like the Great Red Spot, it's been around for hundreds of years. But while the Great Red Spot rotates counterclockwise, this one rotates clockwise. And that difference in rotation is key to understanding what's happening in the Great Blue Spot. See, high pressure means that air is rising. So as both storms rise above Jupiter's surface, they carry material with them. But the clockwise storm sucks up hydrogen and helium from the atmosphere, while the counterclockwise storm sucks up ammonia ice. And when the two meet, the ammonia ice forms a solid shell that gets blown around the planet by Jupiter's winds. That shell is what's called a hailstone, and it's made of ice. Now, as far as hailstones go, this one is humongous. It's around 30 meters wide and weighs about 100 tons. And it orbits Jupiter every 6 days at a speed of 618 kilometers per hour. And that makes it a serious threat to anything unlucky enough to get in its way. For example, when it collides with a ship-sized chunk of debris, it can smash it to atoms. But somehow the Great Blue Spot is completely immune to the hailstorms raging just 3,000 kilometers away. And scientists think they know why. Hailstones are magnetic, so they interact with Jupiter's magnetic field. And that interaction creates electric currents inside the hailstones. And those currents generate their own magnetic fields. Those magnetic fields repel the ionized gas that normally makes up Jupiter's auroras. And that repulsion is what keeps the hailstones from being destroyed, but the Great Blue Spot is different. For some reason, the particles in the auroras aren't repelled by the hailstones. They're attracted to them, and that attraction is what keeps the Great Blue Spot from dispersing into Jupiter's atmosphere. Now, like I said earlier, magnetic fields can interact in interesting ways, and that includes interacting with themselves. If the Great Blue Spot is a giant bar magnet, then its magnetic field lines will interact with the magnetic field lines created by the hailstones. And that interaction could be powerful enough to trap the auroral particles in the Great Blue Spot. But that raises another question. Why are the particles attracted to the hailstones in the first place? Well, scientists think it has to do with the shape of the hailstone. As it moves around Jupiter, it creates shock waves that form standing wave patterns. And those patterns amplify the magnetic field lines coming from Jupiter's core. And that amplification is what attracts the auroral particles. But again, that raises another question. Why would Jupiter have such large hailstones in the first place? Well, honestly, that's a question for another video. But the short answer is that it all has to do with Jupiter's winds. As far as scientists can tell, the storms on Jupiter are powered by heat coming from below the visible surface. That heat rises toward the surface, creating rising air currents. And when those air currents reach the visible surface, they form storms. And the stronger the rising air currents, the bigger the hailstones. And the stronger the hailstorms, the stronger the magnetic fields generated by the hailstones. And the stronger the magnetic fields, the easier it is to trap the auroral particles. So that's what might be causing the Great Blue Spot, a runaway cycle of hailstorms and trapped auroral particles. But that's just a theory. We won't know for sure until Juno makes another discovery. After all, this is just the latest chapter in an ongoing investigation. Juno launched in 2009 and arrived at Jupiter in 2016, and its mission was originally planned to last 5 years. But Juno is still going strong, and thanks to a successful engine burn in 2021, NASA was able to extend its mission all the way to 2025. So we may not have to wait too long before we find out what's behind one of the most bizarre mysteries in our solar system. If you liked learning all of this stuff about Jupiter and its moons, you'll love our series Cosmos, a space-time odyssey. All 13 episodes are available on a streaming service. Thanks for watching.